Coding. Okay, so last time we introduced, after having dealt with square root, we introduced, the higher roots, cube root in particular, cube roots, fourth root, etc., etc. So we're going to try to practice a little bit something about the cube root. So let me go ahead and share my screen. Okay. Window. All right. So everybody is able to see my file.
Yes.
All right. So for instance, we can say simplify. For instance, cube root of 54. Okay. So what we did practice is how to simplify square root of a number. So everybody remembers what you have to do. You have to break down that number into a perfect square and then another number. All right. So for instance, if you come back a little bit, if this was square root of 54, right? And we want to simplify square root of 54. How we would break down 54? What numbers we're going to use to simplify square root of 54? What numbers we're going to use? What do you think?
Is that 9 and 6?
Thank you very much. We would use 9 and 6 because we want one of them to be a perfect square, right?
Right.
Okay, we want one of them to be a perfect square, so we would use 9 and 6, right? But here, are we interested in the perfect squares or perfect cubes? We are interested into having two numbers and one of them to be a perfect cube, right? So then, in that case, is 9 and 6 with 9 and 6? Will they help me then?
No.
No.
Oh, what are the perfect cubes? We have 1 is a perfect cube. We have 8 is a perfect cube, right? We have 27 is a perfect cube. We have 64 is a perfect cube. We have 125 is a perfect cube, and so on. You see, I have exhausted my mental math. So
is it 20?
After that, I have to use a calculator. So the 1 is 1 cube. 8 is 2 cubes, right? 27 is 3 cubes. 64 is 4 cubed. 125 is 5 cubed.
Actually, I just did some quick calculations. 27 goes into 54 twice, and 27 is a perfect cube. Could that help?
Exactly. That is absolutely correct. So here, the numbers that are going to help us rather are 27 and 2, right? These are the numbers that will help us in this case. Okay, so we will have then square root, cube root of 27 times 2. Now we said the 27 gets out and becomes what?
3.
3, because the cube root of 27 is 3, and then cube root of 2. Please, when you write the cube root, do not forget the index 3. If you don't put the index 3, it becomes what? You know, some students in the past, I see them write this. Somehow during the process, the index 3 is lost. But here, what I did now, do I read the cube root still? Is it cube root still? If I don't put the index 3, what I read?
That's now square root of 2, which
That's
is the difference with cube root of 2.
So don't forget the index 3. Don't forget that, right? Okay, so simplify cube root of 72 Go ahead. Simplify cube root of 72 and 8 times cube root of 250.
I have a question.
Yes.
I wasn't here last class because I wasn't feeling well, but I'm new to Microsoft Teams. So do we have to check for a code each time we have class?
No, actually we have I sent the link. There is no code. I think you go to the link. The link will bring you exactly directly to the meeting. You see,
Okay,
and the link is on and we have the thing is we have two different links for Tuesday class and for Thursday class.
okay, but they'll always be the same.
Yes, they will be the same. It is a recurring. These are recurring meetings. The only thing is, unfortunately, we couldn't do it like for one link for for each session like Zoom. For Teams is more complicated, so we have to do two links if you want them to be recurring.
Okay.
Yeah. Okay. All right. So, okay. So right here, how you broke down the number 72? If you want to simplify it, You want to break down 72 as what?
8 and 9.
9 and 8. Everybody agrees with that?
Yes.
Again, why we don't choose 36 and 2? Why we don't choose 36 and 2? What is the reason?
Because neither one of those is a cube.
Exactly, because neither one of them is a perfect cube. So we're going to go with 9 and 8, right? So it's going to be cube root of 8 times 9, right? The cube root of 8 is 2, and then cube root of 9, right? Okay, and then, okay, you see, this is a new sum. Let me answer to this. You know, some students trying to come to class, and that is okay.
Wait, I'm confused. I thought you pulled the cube out.
The cube root out. Yeah, what is cube? How much is cube root of 8?
It's not a cube.
8 is a perfect cube. What is 2 cubes?
Oh my gosh.
Yeah, it's not a perfect square, but it is a perfect cube. Yes.
Whoops.
Right. Okay. So, okay, for the next one. Yeah, some students having, you know, difficulty to come into this class. So I'm giving them the link. Okay. All right. What about the next one? What numbers are you going to use?
I can do it. It's 125 and 2.
125 and 2, right?
Mm-hmm.
Thank you. Now, what you do next?
The cube of 125 is 5.
Uh-huh.
So I multiply 5 times 8.
Exactly.
Which is 40. Okay. And then I put the cube and then 2 on the inside.
Exactly. It's going to be 40 cube root of 2. All right. So this is, so now, of course, you know, will I play with, you know, 4th root, 5th root, 6th root? I don't. Hello, Haley. Can you please go to Teams? We are not in Zoom, we are in Teams. And the link is on right. Yes, go ahead. No, I think you are in the Tuesday meeting. You know, we have 2 different links. Unfortunately, we have to set up a link for Tuesday and a link for Thursday. Oh, okay. So when you go back to the announcement, you're going to see the Thursday link. All right. So, yeah, I don't know why Zoom, you know, went back to trying to get money, you know. They are disrupting everybody. Okay. So right here. So last time, what you said last time, you said if you have square root, when you square square root, what you get? They cancel out, right? You agree with that? This is what you said last time. Square root and square cancel each other. Now, what do you think what's going to happen to the cube root? If you have cube root, if you want the 2 powers to cancel, what power should be on the A?
1.
Just common sense. What power should be on the A here for them to cancel out?
3.
Power 3. You see, when you multiply a number 3 times and then you take the cube root, it is very, very normal that they cancel each other, right? You get A. Okay, it's
What
very
would happen
normal.
if you had an A squared inside a cube root?
So then they don't cancel out. And we can give an example. Look, if you say cube root of 4 square, right? You see here, this power and this power don't match, right? Let's see if they cancel each other. What is 4 squared?
16.
16. What is cube root of 16? Is that 4?
I think it's 2.
It's not 4. No, it's not even 2. Cube root of 16 is not like an exact number, right? It's going to be 2 point something, you see?
So you leave it as that because it's an
Yes,
irrational number.
but now make them match now. Now, if you make them match, cube root of 4 cubed. What is 4 cubed? 4 times 4 times 4, 3 times. How much is that?
64?
64. What is cube root of 64?
4.
4. You see? So instead of passing through this step, you can go ahead and just cancel them out, right? Okay? So when a variable is non-negative, when the index of the radical and the power inside, when they match, they cancel each other, okay? When they match, when the power inside and the power outside match, they cancel each other. All right? So, right here, from this remark right here, we're going to do this. What do you think is cube root of a cubed? This is a, right? Okay. In the same token, what's going to be cube root of a to the 6, you think?
A cubed.
It's going to be
A cubed.
a cubed. Okay, so let's break it down a little bit.
Okay.
A to the 6, a to the 6th power can be written as a cube. The cube of what power of a?
2.
The cube of a squared. Everybody agree with that?
Oh, okay.
Everybody agrees with this writing? What is 3 times 2?
6.
It's 6, right?
Yeah.
You see, I need to match. But here, we are more eager to push the 3 out, the 3, you know, because we wanted to cancel with the cube root, right? Okay, so instead of putting a 3 square, we wanted to write it this way, because this way we want this 3 outside to cancel with the 3 here. So if we say this cube root of a square and then cubed, you see what happened to them? This two cancel out, right? This is a square. Okay, so look at the initial exponent, look at the final exponent, right? As if we divided 6 by how much? As if we divided 6 by how much? To get the final answer, to final exponent, we divided 6 by
3. Oh, 6.
by 3. By 3. The same way square root divides exponents by 2, it is the same way cube root divides exponents by 3. Okay? Cube root will divide exponents by 3. For instance, when you do cube root of a to the 12, what's going to be the answer then? A to what power? A to the?
4.
What's going to be the answer? A to the 4th, right? It's like, you know, do 12 divided by 3. Okay? Cube root will divide each exponent by 3. The same way square root divide them by 2 is the same way cube root divide them by 3, right? So cube root of a to the 21, how much is that then? A to what power then?
7.
8 to the 7th, right? So let me put you this. All them numbers that are actually the good numbers. So What is cube root of x to the 15th? What is cube root of a 9 b to the 24? What is cube root a cubed Okay, go ahead, everybody. All right, so you see, these are the, if you retain what we just said, these are the examples where the answer is right there, right? Okay, so for instance, the first one, what's going to be the answer? Is x to what power?
The
X to
fifth.
what power?
To the 5th.
X to the 5th, right? Okay, the second one, what's going to be the answer?
A to the third, B to the eighth.
A to the 3rd,
And then B to the eighth power.
B to the 8th. And everybody in this room knows where the 3 come from and when the 8 come from? All of us know? Okay. So now the last one here. What's going to be the answer for the last one?
So the 3's, the 3. Oh,
Uh-huh.
yeah. I didn't know if the A just gets canceled out entirely.
Yeah, the exponents cancel out, but it's going to be a to the 1 power. Like 3 divided by 3 is 1.
B to
We just don't have to write the 1, right?
B to the 6th.
B to the 6 and C to the what?
10th.
To this, exactly. But now you can guess what's going to be the case. What's going to be the more annoying case? Somebody tell me. If what? Can you tell me what's going to be the case that's going to be a little bit more annoying if
it doesn't divide evenly?
Exactly. Thank you very much. If the exponent is not an exact multiple of 3, right? Like what? Like x to the 4th. You see, for instance, cube root of x to the 4th. You see? Unfortunately here, the exponent 4 does not divide evenly by 3, right? But we're going to do the same stuff we did with square root. In the case of square root, it was easier because we are just to break down the exponent as an even number and 1, right? But here, we're going to break it down as of multiple of 3 and some number, some remaining, right? What is a multiple of 3 that is next to 4?
3.
It's 3 itself, right? It's going to be x cubed. How many exponents remain?
1.
1. Everybody see that? Everybody agree with this breakdown? 3 plus 1 is 4, right? Okay, so why I do that? Because this one is a good exponent, right? Isn't it? Because this one is an exact multiple of 3, right? So it's going to be, and these two cancel out. 3 divided by 3 is 1, and then going to be cube root of x. You see?
It makes me think of factoring.
Mm-hmm. Kind of, right? So, for instance, we say cube root of x to the 17. Same thing. Unfortunately, 17 does not divide evenly into by 3, right? But how are we going to write it down? We're going to write 17. We're going to break it down into 2 exponents. One of them is a multiple of 3. The other one is the remaining, right? The remainder. What numbers come to your mind?
16. So
Is 16 a multiple of 3?
wait, something that gets to 16. A multiple of 3.
Yeah.
Never
What
mind.
is the closest multiple of 3? What
5
is
times
the close? It is
5 times 3.
exactly is 15, right?
Yes.
5 times 3, which is 15, exactly. So we're going to use that, right? So we're going to use that. So we're going to use 15, the exponent 15. How many exponents remain?
2.
2 remain, right? Everybody agree with this breakdown again before we move on? Again, what we want? We want to break down any exponent that does not divide evenly by 3. We want to break it down into the number that divides evenly by 3 and then the remainder, right? You see, 15 is a good number. Now, the x to the 15 can go out because 15 is a good number. But when it goes out, it becomes what? What power is it going to become? X to what power?
The 5th.
X to the 5th, 15 divided by 3. And then the other one, there's nothing to do with it. We just leave it like that. Okay? Everybody see that? Now look, for all of us who knows the division very well, look at the powers inside right here. The powers in my answer. When you divide 17 by 3, when you do this division right here, 17 divided by 3, how many times 3 goes into 17? Is it 5 times? That is a 5 here. 5 times 3 is what? 15. What remains? 2. That is a 2 right here. Okay? In my answer, I will always see how many times the number 3 goes into that number, 17, and then the remainder. Okay? All right, so this is how we divide cube root. So I'm going to give you some more here. Simplify. Cube root all right, and then one last one. Okay, I'm going to choose like some good 5 minutes, everybody. You see? All right, so what do you think? I think it's been 5 minutes, I think. Okay, the first one, how are you gonna break down the power 10? If you wanna simplify this stuff.
You would do 5 times 2, or x to the 5th, x to the 2nd.
X to the 5th and x to the 2nd?
Yes.
Okay, so now you have to look. Okay, first of all, when you do x to the 5th times x to the 2nd, when you add them up, you don't get 10. See, the two exponents here, when you add them up, not when you multiply, when you add them up, it should be 10, right?
X to the 9th, x to the 1 first.
Exactly. 9 and 1, x to the 9 times x to the 1 power, right? Why we choose 9? Because
It's a perfect cube.
9 is a perfect cube, right? Because 9, when you divide 9 by 3, there's no remainder, right? That is the reason we choose 9. Okay, we didn't choose 8, we didn't choose 7, because they don't divide into 3, okay? So 9 is the closest multiple of 3 to 10. And when the x to the 9 goes out, it becomes x to what power?
X to the 3rd.
X to the 3, because 9 divided by 3 is how much? It's 3, right? And then cube root of x.
Yes.
All right, thank you very much. The second example right here. The 8 to the 23rd, what powers we're going to use? 8 what and 8 what?
$18 and 5.
You say 18 and 5? Okay, you see 18 a good number, but can we do better? You have another number before 23, between 18 and 23, that also can be divided by 3. 18 a good number, but we can do better.
21. Sorry.
21, yes. 21 is a better number because 21 now is the closest multiple of 3 to 23. 21, how much power remain?
2.
2, right? So basically, and then the 21 goes out, becomes what?
7, A7.
A to the 7, and then we have a cube root of
2.
A,
A to the
right?
2. Yeah.
Exactly, thank you. So now we're going to deal with the B's.
May I don't want to hold up the class and ask a question that's not. What happened to canceling out the 3s?
The 3s?
Why wouldn't it be A to the 20th and A to the 3rd, and then you cross out the 3?
Oh, okay, you mean this one right here?
Yeah.
A to the 23?
Weren't we just crossing out 3s a second ago?
Yeah, but we cross 3 is the whole power is 3, right? But here the power is 23. You see, we cross out the 3's, for instance, we say cube root of A to the 3. These two cross out, right?
Right.
But you don't have A to the 3, you have A to the 23. You see?
Yeah,
the power,
but then just leave the remainder.
yeah, and this is exactly what we did. You see here, why we broke it down into the two numbers 21 and 2? Because 21 can be evenly divided by 3. That's the whole thing. That's the whole thing. And then where's the 7 come from, you think? Where's this 7 come from?
Well,
21 divided by
7.
21 divided by 3 is 7. Okay? This is where the 7 come from. 21 divided by 3 gives you A to the 7th, right? Okay? So what we did here, look, this is the phrase we have to remember. Cube root will divide your power by 3. Okay? Cube root divides exponents by 3. Now, you have two types of exponents. The one you can evenly divide by 3, and the one you cannot evenly divide it by 3. If you can divide it evenly by 3, you don't need to do all this breakdown. For instance, look at this number right here in the last example, for instance. 18. Can we divide exactly 18 by 3? 18 can be divided by 3 evenly, right?
Yes, 6.
What in 18 over 3 is? 6. So here I will have a to the 6th power, and there will be no a left inside the cube root. It's all gone. Because 18 divided by 3 is 6. That's it. Okay? Now, the issue is when the number cannot be evenly divided by 3. When the number cannot be evenly divided by 3, this is when we have to do this breakdown right here, for instance. 23, we all know 23. When you divide it by 3, there is a remainder, right? Okay? So what you're going to do, we're going to break down 23 into 2 numbers. One of them can be evenly divided by 3 and then some remainder, right? Which is 21 and 2. Now the 21, since it can be evenly divided by 3, we can simplify it completely. It simplifies into a to the 7th, right? But the 2 here will remain inside the cube root. The 19 here, which power I'm going to use? How am I going to break down 19? Beat what power and beat what power? What number I'm going to use?
To 15th and to the 4th.
You see, okay, thank you very much for saying 15. 15 is good, but it's not the optimum choice, okay? Because you have 15 here, you have 19 here. When you go from 15 and 19, do you reach another multiple of 3?
18.
18 is the best choice, right?
Oh, okay.
You see, we always get the best one, you know, the one that is the last one, okay? That is 18, and then we have one remainder, right? And then we can simplify cube root of b to the 18, we can simplify it completely, it becomes b to what power? How much is 18 divided by 3?
To the 6.
B to the 6. What remain? 1b. Everybody see that? Now comes the last one, 5. Okay, 5, we don't look like very far. 5 is c to the 3rd and c squared, right? You see? And the c to the 3rd can be completely simplified. 3 divided by 3 is 1. It's going to be c to the 1 power and then c squared left. Okay? So everything here is a matter of division. We're just dividing exponent by 3. It is a division of the exponent by 3. Okay? You have the quotient and you have the remainder, right? You see, if somebody is very good at the division right here, when you divide 23 by 3, how many times you get? How many times 3 goes into 23? 7 times, right? How much remains? 2 remains, you see? Now look at the answer. The 7 here is here, and the 2 is here, right? Okay. Now the last example right here, before we do the a to the stuff, let's do step by step. The 24, how are you going to break down the number 24 to get a perfect cube and then another number? Which number are you going to use, 24?
8 and 3.
8 and 3, right? Everybody agrees we're going to use 8 and 3?
Yes.
Because 8 is a perfect
Cube.
cube, right? What is cube root of 8?
2.
Is 2. And then we have cube root of 3 left. Cube root of 3 left inside, right?
Yes.
A to the 18. 18 is in it. How much is 18 divided by 3?
6.
Do we have any remainder?
No.
No remainder. It's just a to the 6. Now 26. 26, when you divide it by 3, you have a remainder. That is when you need to break it down. Which power I'm going to use? The optimum powers is 20.
21.
Okay, when you say 21 again and 26.
24. I'm sorry.
Exactly, 24. And how much remain?
2.
2.
That's
What is 20? Exactly. What is 24 divided by 3?
8.
8 is b to the 8 here and then b squared left inside.
Yeah.
C to the 13th, right?
It's 12.
Of course, we're going to use 12 and
1.
and 1. 12 divided by 3 is
4.
4 and then C. Okay? That's good. It's a test or quiz or whatever. You will never see something harder than that. It's going to be the same stuff, right? It's going to be exactly the same stuff. Okay, so that is how to simplify radicals. Is very important, right? How to simplify radicals. In the test, it's going to be more about square root rather than cube roots. Okay? It's going to be more about square root rather than cube roots, because we know we don't want to be like a calculation stuff, right? Because cube root.
When is the next test?
I mean, the next quiz will be next week, right? So the next quiz will be next week. When you go to if I open up your syllabus, right? Let me do it right now. When you open up the syllabus, by the way, you know, all the calendar is in the syllabus, you know, which is on Brightspace. So when I open up the syllabus, I have to make sure I don't say something wrong, something false. Okay, the next quiz is scheduled next Tuesday, right after class, right? You know, so quiz is like a take-home quiz, okay? Just like quiz number 1, all right? So it's going to be it's going to be scheduled on Brightspace. I will open it up on Brightspace after class, and you will have until the next day to do it. You will have about 24 hours to complete the quiz, and then upload it on Brightspace, just like quiz number 1, okay? Just like quiz number 1. So please don't miss it. If something is open for like 24 hours, and it's going to take you probably 20 minutes, 30 minutes to do it, you cannot say I couldn't do it, okay? You know, you have to do it, you know. And something very important, when somebody misses a quiz or a test, the makeup is not automatic. The makeup is, I have to follow the rules. So makeup is not automatic. It's going to be a 0 until proved otherwise, okay? All right. And that is the next quiz. The next test is like, you know, November the 2nd. That's test number 2. All right. So what you're going to do next year is the section 3.3 is how to add radicals, how to subtract radicals. That is the next section, how to add radicals, how to subtract radicals. Add and subtract radical expressions. Add and subtract radical expressions. Okay, so here, we just going to follow the algebra rule. What the algebra rule says? Group like terms. When we group like terms, if 2 terms are like, they look alike, we can group them. It doesn't matter what they mean. You see, for instance, if I say 3x plus 5x, do you tell me I have to let you know what is x to be able to do that? Or what you going to say? How much is 3x plus 5x?
8x.
Everybody knows this. That is 8x. Do we really care what x is? As long as they look alike, right? They are like terms. You see, when you have like terms, these 2 are like terms, what you do? We just add the numbers in front, right? It's 3 plus 5, which is 8. It's going to be 8x, right? Okay, it's like when we say 3 apples plus 5 apples. This is 8 apples, right? 3 cars plus 5 cars. This is 8 cars, right? They have to be like terms, right? If they are not like terms, we cannot add them up. You see, you cannot add 3 cars plus 5 apples, right? What can you do with that? Can you say 8 something? You just say 3 cars plus 5 apples. We cannot put them together, okay? So it is the same thing. When you have like radicals, you just add them up if they are like radicals, right? For instance, we say 3 square root of 7 plus 5 square root of 7. The radicals you see, are they exactly the same? The two radicals you see,
Yes.
are they exactly the same? They are like radicals, right? You see, they are like radicals. If they are like radicals, what we do, we just add them up. Add 3 plus 5 is 8, square root of 7. Everybody see that? Okay? If they are like radicals, we just add them up. For instance, right here, when you say 17 cube root of 10 minus 5 cube root of 10, right? The radicals you see, the two radicals you see, are they exactly like radicals? Are they exactly the same?
Yes.
They are the same. So what's going to be the answer then?
12 cube root of 10.
Exactly 12 cube root of 10. It's like saying 17 cars minus 5 cars is 12 cars, right? Okay? But they have to be like radicals. If they are not like radicals, like somebody tells you 2 square root of 11 plus 8 square root of 13. You see, this we cannot do nothing about this, okay? We cannot put them together because they are not like radicals, right? And there's no way to make them become like radicals, okay? 11, squares of 11 and squares of 13 are completely different. They are not like radicals, and there's no way to make them like radicals. So, not like radicals, right? So, we cannot put the 2 and the 8 together. We cannot say 10 something. We cannot say that, okay? So, the easy case will be, if we give you like radicals, simplify. Go ahead, simplify these expressions, please. All right, so here, the first one, are the radicals in the first one like radicals? All of them are like radicals?
Yes.
Okay, they are, right? What's going to be the answer then?
21.
21? You did 9 plus 12, right? What about the last one?
Minus square root of 5.
Yeah, how much is that there? I guess, you are hesitating because you don't see a number in front of the last one, right? But if you don't see a number, what number is supposed to be there?
So is it
1, right? So what numbers you're going to put together? You're going to do 9 plus 12 minus 1, which is what? 20. Okay? So when you do, if the radical is like this by itself, suppose you have 1 in front of it, right? Just like here, suppose you have 1 in front of it, okay? You see, same one here. What you going to do? What's going to be the answer for the next one? Are they like radical, first of all?
yes?
They are. What's going to be the answer then? What?
So it's going to be -5.
Negative what?
-5.
Negative 6, right? Is 4. You're going to do 4 minus 9 minus 1, which is -6. Is a -6 cube root of 17.
Wait,
Okay.
I did that. I did it the second time, but I didn't do the first time because I swear I put -6. I swear.
Yeah, I agree. I believe you. Yeah. You got -6. Okay. All right. So they are like radicals. Okay. So now, what do you think? Do you think it's going to be like that? Only the number is going to be like radicals, and that's it. So we learn everything? No. Unfortunately, no. Unfortunately, no. What's going to be likely to be in the test, for instance? It's going to be something like that. You see, we say, for instance, we say 10 square root of 2 plus square root of 18.
Ah, crap.
You see? You see, it's going to be something like that. The two radicals, are they like radicals yet?
Not yet.
Not yet. But what's going to happen? We're going to try to make them like radicals. And that is the case you're going to see on the test. At first, the first sight, they are not like radicals. But we're going to try to make them like radicals by simplifying some of them, right? You see, here, 18 can be simplified as what? Remember what we used to do? We're going to break down 18 as what and what?
9 and 2.
9 and 2, thank you. And the 9 goes out, becomes what number?
3.
The 9 goes out and becomes a 3. So it's going to be 10 root 2 plus 3 root 2. Now what's going to happen now? Do I see like radicals now? What is the answer?
13 square root of 2.
13 square root of 2. Everybody see that? This is what you're going to see. Okay? So for instance, we say 8 root of 3 minus or plus, right? 7 root of 12 minus you see, right? Some like that, right here. All right, what's the answer you got? Somebody.
11 square root of 3.
11 square root of 3. Everybody agree with that? Okay, tell me what you did to get that first.
I broke down the 12 into 3 times 4.
Thank you.
And I broke down the 75 into 25 and 3.
Thank you. Right.
And then
Agree with that.
that gives you like radicals. So then, yeah. And then
Okay, plus what?
what is it? 7 times 4.
Is it 7 times 4? When the 4 gets out, it becomes what number?
Oh,
When the 4 gets out, it becomes square root of 4, which is how much?
2.
Which is 2. It's 7 times 2 square root of 3, right?
Yeah.
Minus, and then when the 25 gets out, it becomes what number?
5.
5 squares of 3, you see? And that is 14 right here. It's going to be 8 plus 14 minus 5, right?
Yeah.
Okay. 8 plus 14, 22, minus 5 is 17, is 17 square root of 3. Everybody agree with that? Okay, so let's do another one. All right, everybody, try to do that one right here. All right, so Somebody got an answer?
I got -6 with the square root of 5.
-6 square root of 5?
Mhm.
You can confirm that?
I could try.
Okay.
Confirm it.
Yeah, if you have like, if two people got the same answer, then it must be the right one.
Yes.
Okay. The 20, okay, you broke down 20, what numbers?
The 20, I did 4 and 5.
4 and 5. And the
Yep.
45 as what?
5 and 9.
Exactly. So when this 4 gets out, it becomes what number?
A 2.
Will be 23 times 2, and then root of 5, right? And when the 9 gets out, it becomes what number?
3.
3, and then root of 5.
Mhm.
See? So we get 19 root of 5 minus 46 root of 5. I mean, you can mute yourself, somebody.
Yeah.
21 root of 5, right?
Yes, I'm
Okay.
sharing a room with my granddaughter doing our
Okay, yes, whatever. So it's going to be 40, and then minus 46 is going to be -6 root of 5. All right? So do everybody agree with that?
Yes.
Okay. So this is addition or subtraction of radical exponent. So we can do the same thing with, with the cube roots. We can do the same thing with the cube root. For instance, we can say cube root of 7 cube root of 2 minus 3 cube root of 8. No, I'm sorry. 3 cube root of 16, right? Plus you see, something like that. Same thing. But now it's about cube roots now. It's not square roots, it's cube roots. Now, the way we're going to break down the number will be a little bit different, right?
Yeah, see, I was confused with that a little bit with the last problem because, it didn't specify whether it was a cube root or a square root. So we could, like with the 9, when we brought out the 9, we could just turn it into a 3. And with the 4, we could just turn it into a 2.
Yes. Yes.
There was specification, right?
Yeah, I mean, the square root and the cube root are visually different. The square root, basically, you don't see no index on top of it. But the cube root, you're always going to see the index on top of it. You're going to be the index 3 right there. You see? That is cube root right here. See? If you don't put nothing, if you don't see nothing, it is a square root. And then it's going to be all about having a perfect square, like 4, like 9, you see? Yeah. But here, it is a cube root. It's going to be all about having a perfect cube. Numbers like 8, numbers like 27, numbers like 64. These are the perfect cubes, right? Okay, so here, for instance, 54, if somebody breaks down 54 as 9 and 6, no help. It doesn't help you because 9 is not a perfect cube, 6 is not a perfect cube, right? Okay, so we have to break down those two numbers, 16 and 54, using the perfect cubes that you see on the left side. For instance, 16 can be broken down as what and what?
2 and 8.
2 and 8, right? 8 is a very nice number, very important number, because 8 is a perfect cube. 54 will be broken down as what and what?
2 and 27.
27 and 2, thank you, right? Because 27 is a perfect cube. Okay, so once we get that, now the perfect cubes, they can get out and become other numbers, you see. The 8 is a perfect cube, so it gets out and it become a 2. So it be 7 cube root of 2 minus 3 times 2 cube root of 2, right? And the 27 gets out and it become a 3 cube root of 2. All right. So plus here. Okay, and then we just group the numbers. This is 6 right here. It's 7 minus 6, which is 1. 1 plus 3 is 4. It's going to be 4 cube root of 2. All right. This is how we add radicals. Of course, in the test, you know, or the quiz, there's going to be likely something like that. You see, the radicals at first, they will not match, and then you have to simplify to make them match. Okay, so like I said, next week, we will have quiz number 2 next week, right? And it's going to be on Blackboard, okay? I mean, not Blackboard, Brightspace. I will open it right after class, probably like 1 o'clock or 12:30, right? And it's going to be available until the next day, all right? So we'll have like 24 hours, at least 24 hours. You know, I mean, not say at least, it's going to be exactly 24 hours to do it. You just do it exactly like quiz number 1. When you go to quiz, you're going to see the papers, the PDF. You write it, and then you go back to the assignments where you see submit your quiz here, your quiz 2 here, and then you upload your file or your picture, okay? So, and then meanwhile, I will calculate your progress grade, what they call progress grade. I will include test number 1. I will include quiz number 1, and whatever we done with the homework, whatever sets are closed, only the closed sets, right? I will give you a snapshot of how you're doing in this class so far, okay? It's going to include quiz 1, test 1, and then I don't want to include the quiz number 2 because it's going to be misleading, okay? Because, you know, the test has more weight. I'm going to include only test 1, quiz 1, and whatever done in the homework for chapter 1, chapter 2, okay?
Sorry, the quiz that we're having on Tuesday, is it just going to be on the square roots that we've been going over?
Yeah, the quiz. Thank you. So that's a good question. Let me write it here. The quiz number 2 will be on. Everybody write that. Quiz number 2 is going to be on. I think it's going to be rational functions, no, rational equations. Okay, one question. It's going to be a work problem, like sharing the job, you know, like 2 people, this works this, etc., etc. It's going to be simplifying radicals. Which is 3.1 and 3.2, right? And then add subtract radicals, which is 3.3. So the rational equation, I think this was 2.6, if I'm not mistaken, and this was 2.7, right? Something like that, okay? Let me make sure about the sections. Yeah, it was 2.6 and 2.7, yes. That's going to be the quiz number 2. You know, something like 5 questions, probably, you know. All right, everybody. So for Teams, you don't have to write your name because we can upload the attendance sheet, right? That is what is cool about Teams. You can upload the attendance, so you don't have to write your name. So it tells me when everybody, it was here, and if somebody left, it tells me when they left also. Okay. All right. You see, and yeah. All right, everybody. See you next week.
Bye. Thank you.
Thank you very
Bye,
much.
everybody. Thank
Bye.
you.
Bye, thank you.
Thank you very much.
Oh, what did we get for the answer on the last question?